Hi folks, this is Checkpoint Quiz 12. Number 1, we're given a sequence defined recursively, and we're asked to write out the first 4 terms of the sequence and discuss whether or not it converges. Okay, so a recursive sequence tells us where to start. So it tells us a1 is 3, and then the recursion equation, an plus 1, is 5 minus an, and that recursion equation holds for n bigger than or equal to 1. So what we do is we substitute n into the recursion equation. So everywhere I see an n, I'm going to plug in 1. I get a1 plus 1 is 5 minus a1. So a2 is 5 minus a1. So to get a2, I'm going to use a1, and I'm told that a1 is equal to 3. So a2 is 5 minus 3, which is 2. So a2 is 2. Now I move on to n equals 2. The recursion equation is a sub 2 plus 1 is 5 minus a sub 2. So a3 is 5 minus a2. And I know what a2 is. I just determined a2 is 2. So this is 5 minus 2. And so a2 is equal, a3 rather is equal to 3. Now I look at n equals 3. I plug that into the recursion equation. A sub 3 plus 1 is 5 minus a sub 3. So a4 is 5 minus a3. So a4 is 5 minus a3, which is 3. And so I get a4 is equal to 2. So the first 4 terms of the sequence are a1, a2, a3, a4. And a1 is 3, then 2, then 3, then 2. So if you look at the recursion equation, the way you go from one term to the next, all right, is you take 5 minus the term that you have. So 5 minus 3 gives you 2. 5 minus 2 gives you 3 again. 5 minus 3 gives you 2. Then 5 minus 2 gives you 3. And so you see this alternating pattern between 3's and 2's. Well, as n goes off to infinity, this will continue to alternate between 3 and 2, 3 and 2. And so as n goes to infinity, or I guess we should say the limit, as n goes to infinity of a sub n does not exist, because it continues to oscillate between 3 and 2. And so it never settles down and gets close to any one real number. That'll do it for number 1. Number 2, we're asked to find the limit of this sequence, and a couple ways we can proceed. I know a lot of you like L'Hopital's rule. If you're going to use L'Hopital's rule, though, you have to change this into a limit on x. So if you want to do L'Hopital's rule, you have to pass it to a continuous variable. And I know this just seems like semantics, but these sequences are technically functions of natural numbers. In order to use L'Hopital's rule, we need derivatives, so we need functions of real numbers. So one way to proceed is go off and L'Hopital your way through it. Of course, you know, when you can just use algebra and limit properties, I always favor that. You can do L'Hopital, it's not wrong, but we can always go back to the Calc 1 methodology. We'll factor out the highest power of n in the numerator, and then we'll factor out the highest power of n in the denominator, like so. And then those things cancel out. Oh, I meant to do that in red there for effect. That's all right. And so I get the limit as n goes to infinity of 3 over 1 over n squared minus 4. Now I can use my limit properties. As n goes to infinity, 3 doesn't depend upon n at all, so it's going to go to 3. The 4 is going to go to the 4. The 1 over n squared is going to go to 0. And so using limit properties, we get our answer is 3 over 0 minus 4, or negative 3/4. That'll do it for number 2. All right, number 3, we're asked to prove the sequence here is non-increasing and bounded below. Okay, so one way to try to do this, to show a sequence is non-increasing, is we can replace the n, the discrete variable, with x, the continuous variable, and look at the associated function f of x. So if we do that in this case, we get 4 to the x, which we understand. But what the heck is x factorial? One way, if this worked out, if we got a function of x out of this, we could take the derivative, show it's always negative, and we're done. Okay, but we can't do that in this case because x factorial doesn't make any sense. So we have to go back to the definition of non-increasing. So non-increasing means that whatever term you have, the next one can be no bigger than it. So as you go down the sequence from an to an plus 1 is less than or equal to an. And we have to show this is true for n bigger than or equal to 3. So we start off with our scratch work here. We write down what we want, and then we see if we can get that to work out. So what I want is I want an to be bigger than or equal to an plus 1. An is 4 to the n over n factorial. And I want that to be bigger than or equal to an plus 1. So everywhere I see an n, I replace it with n plus 1. That's what I want. And so I'm going to work through and see if I can get this to work. So I'm going to gather all the exponential parts on one side and all the n's on the other. So I'm going to multiply both sides by n plus 1 factorial and divide both sides by 4 to the n. Since n represents a natural number bigger than or equal to 3, everything I'm manipulating here are positive numbers. So that means I don't have to reverse any inequalities. So this inequality is equivalent to that inequality, and now I simplify the ratio of factorials. And remember, with factorials, when in doubt, write it out. N plus 1 factorial means n plus 1 times n all the way down to 1. And n factorial means n times n minus 1 all the way down to 1. So the ratio of n plus 1 factorial over n factorial is just going to be n plus 1. And I need that to be greater than or equal to. This division I subtract and I get 4, which means n would have to be bigger than or equal to 3. Well, surprise, surprise, that's exactly the condition I started with. So, 4, n bigger than or equal to 3, n plus 1 is bigger than or equal to 4, and I'm just going to reverse my algebra steps. I'm going to rewrite n as n plus 1 factorial over n factorial, and 4 as 4 to the n plus 1 over 4 to the n, and then go through the cross multiplication here and get 4 to the n over n factorial is bigger than or equal to 4 to the n plus 1 over n plus 1 factorial, and that's what I'm calling an, and that's an plus 1, and that's exactly what I needed to show. So hence, the sequence an from n equals 3 to infinity is non-increasing. All right, so there's that. Now I'm asked to show it's bounded below. Okay, so what's it mean to be bounded below? So I look at my an, and what I want to be bounded below is I need some real number m so that an is always bigger than or equal to m for all n here under consideration bigger than or equal to 3. Well, one easy thing to do is you just notice that 4 to the n is always positive, n factorial is always positive. So that means that an is always bigger than or equal to 0. Hence, bounded below. Now, even though this doesn't ask us this, what do we know? I'm just going to write this in here as an afterthought. Since the sequence AN is non-increasing and bounded below, the sequence AN must do what? Converge. This is the completeness of the real numbers that we talked about in class. Okay, so that's sort of the punchline to this problem. Well, that'll do it for Checkpoint Quiz 12.